To determine moment of inertia of composite figures, you need to know moment of inertia of some standard figures. For example, this is a rectangle and its moment of inertia is given by bh cube by 12, where b is the side which is parallel to the axis. For example, if you want to determine moment of inertia with respect to this x dash axis, then this side which is parallel to x dash axis, that is this side, will be b and this side will be h. Similarly, if you want to determine moment of inertia of this rectangle with respect to this y dash axis, then this side you should take b and this side as h. Accordingly, you will get bh cube by 12 as moment of inertia of this rectangle with respect to centroidal axis. Now for triangle, we know that moment of inertia with respect to the centroidal axis is given by bh cube by 36. Similarly, you should also know moment of inertia of this triangle with respect to an axis which is passing through its base will be given by bh cube by 12. Here b is the base, this base is b, and h is the height of the triangle. Similarly, for circle, draw any axis which is passing through its centroid, its moment of inertia will be given by pi r raised to 4 divided by 4. I have drawn here two axes which are along x and y axis. You can draw axis like this, any axis which is passing through its centroid. Moment of inertia will be given by pi r raised to 4 divided by 4. If you take semicircle, that is half of this circle, so if you take the same axis, this axis is same which is drawn here, and similarly this axis is same which is drawn here. So along these two axes, moment of inertia of this semicircle will be half of the circle, that is, it is pi r raised to 4 divided by 4. So if you take half of this value, you will get pi r raised to 4 divided by 8. Now remember that here this x-axis is centroidal axis which is passing through the centroid of semicircle, but this y-axis is not passing through the centroid, so this a centroidal axis. Here centroidal axis which is parallel to y-axis is this one, and if you want to know, if you want to determine moment of inertia of this centroidal axis, this will be given by 0.11 r raised to 4, which can be obtained by applying parallel axis theorem between these two parallel axes. For any orientation, you can give, you will get the same values, only these notations will change. 1/4 of the circle, you can see that again the same y-axis and same axis which we have taken in this circle. In case of this circle, if you take only those x and y-axis, then this will be 1/4 of the circle. So this value, 1/4 of this value you will get, that is pi r raised to 4 divided by 16. Now at this time, this x-axis and this y-axis both are not centroidal axis. Centroidal axis are these. Here centroid is somewhere here, which is 4r by 3 pi distant from y-axis, and similarly 4r by 3 pi distant from x-axis. So about these two axes, it will be half of this value which we have obtained here for semicircle, half of that value. So 0.11 divided by 2 is 0.055 r raised to 4. Here I will be explaining one example, one composite figure. Here we need to determine moment of inertia of this shaded area with respect to centroidal x-axis and y-axis. Now in this particular case, it is very easy to determine centroid, because if you draw this axis, so with respect to this axis, left and right side symmetrical, so centroid will lie in this line. Similarly, when you draw this axis, so about this axis, top portion and bottom portion of this shaded area are symmetrical, therefore centroid should lie in this axis also. Therefore centroid is lying at this point, so you don't need to calculate value of centroid. Directly you can draw these two axes, symmetrical axis, so you have already obtained this centroidal axis. Now to determine moment of inertia of this shaded area, you can divide this entire area into three standard areas. One is this rectangle, so I have written this one is actually this entire rectangle, and two is this semicircle, and this semicircle both are symmetrical, so I have taken only two. So we can of inertia of this shaded area can be obtained using this relation, that is moment of inertia of area 1, that is moment of inertia of this rectangle, and minus moment of inertia of this semicircle. Twice I have taken because two symmetrical semicircles are there. Now first we will determine moment of inertia with respect to x-axis. So moment of inertia of this rectangle with respect to this x-axis, I have drawn this figure again. So this is my rectangle, this is my rectangle. Now in this rectangle, this side is 12 centimeter, and this height, this side is 2.5 plus 2.5 plus this diameter is, radius is 5, so diameter will be 10. So 10 plus 2.5 plus 2.5, so this total distance will be 15. So we know that moment of inertia of this rectangle with respect to centroidal x-axis is given by bh cube by 12, bh cube divided by 12, where b is the side which is parallel to this axis. So this side is 12, so this side is b, and this height is h 15. So by calculating you will get this moment of inertia of this rectangle with respect to x-axis. Similarly, moment of inertia of this semicircle. Now I want to determine moment of inertia of this semicircle with respect to this axis. I have drawn this semicircle and this axis here. So this is my x-axis and this is the semicircle for which I want to determine moment of inertia. Now directly you can determine this is the centroidal x-axis, and we know that moment of inertia of centroidal x-axis of semicircle is given by pi r raised to 4 divided by 8. Now r is the radius of this semicircle, which is 5 centimeter. Pi is 3.14. When you calculate, you will be getting this value. Now put all these values here in this equation, you will get moment of inertia of composite figure. So moment of inertia of composite figures will be 3375 minus 2 into 245.3. So ultimately you are getting 2884.4 centimeter raised to 4. Now for determining moment of inertia of this shaded area with respect to this y-axis. Now for y-axis, again same thing, we have divided it into two areas, 1 and 2. So this will be given by moment of inertia of area 1 with respect to y-axis minus 2 into moment of inertia of area 2 with respect to the same y-axis. This is the same y-axis. Now let's take first rectangle. So I have taken this rectangle and I have drawn this y-axis. Now for this, again the formula is bh cube by 12, here bh cube by 12, but b is the side which is parallel to this axis, so this side is b. So here I have taken this as 15 and this side will be 12. So 15 into 12 cube divided by 12, and if you simplify you will get this value. Now second case, that is slightly difficult one. So that is this semicircle, and you want to determine, this is the semicircle, this is the semicircle 2, area 2, and we want to determine moment of inertia of this semicircle with respect to this axis. So this axis I have drawn this axis. Now centroid of semicircle, we know somewhere here you will get centroid of semicircle which is at a distance of 4r by 3 pi from this side. This is the only side of the semicircle. From that side, its distance of centroid is, we already determined this before, that is 4r by 3 pi. So from this centroid, I can draw another axis which is parallel to this y-axis. So you can say this is a y dash axis. So about this axis, I know moment of inertia. We have in previous example I have shown that this is 0.11 r raised to 4. That will be the moment of inertia of this semicircle with respect to this centroidal y-axis. Now, but we require moment of inertia with respect to this axis. So you can apply parallel axis theorem. So this is the distance between these two parallel axes. So according to parallel axis theorem, I2yy, that is moment of inertia of this area 2 with respect to this axis, is equal to moment of inertia of this semicircle with respect to this centroidal axis plus a into d square. A is area of this semicircle and d is the distance between these two parallel axes. Now you can determine d, value of d. Value of d is total distance. You can see that total distance from this point to this point, this total distance is 6. So this distance from here to here end is 6, and I have already told you that this distance is 4r by 3 pi. So from 6 you can subtract this 4r by 3 pi, then you will get d. So d is equal to 6 minus 4r by 3 pi. Now value of r is known, 5 centimeter. Put that value and you will get this answer, 3.88 centimeter. So d you have obtained. Now area of this semicircle, is 1/2 of pi r square. So again simplify this, you will get this area. Now apply, now I dash yy is 0.11 r raised to 4, that I already told you that moment of inertia with respect to this semicircle, moment of inertia of this semicircle with respect to centroidal y-axis is given by 0.11 r raised to 4. So we calculate this value. Now put all these values in this equation, you will get moment of inertia for area 2. So moment of inertia for area 2 with respect to this axis is given by is obtained as 659.38 centimeter raised to 4. So finally you can get value of Iyy by putting value of these two, I1yy and I2yy, in the above equation, and you will get IYYS at 841.24 centimeter raised to 4. Thank you for watching this video.